So as we kind of get into this, I'm sure that the demographic on this call is very exposed or very familiar with vegetation management. But just to kind of paint the canvas of what we're looking at here, at least domestically here in the US, about 7 million miles of T&D lines that are overhead, about 400,000 transmission, the rest being in distribution networks. As we all know, huge O&M expense line item, especially getting more stringent now as costs are going up, inflation is rising. Arborists are just becoming more and more difficult to find and retain on systems. Pair that with the changing weather due to climate change that we have increasing wildfires, an increasing amount of billion-dollar storms. Things get very difficult as we decide of how do we manage all of this and put this piece together to have the best program for the future. So before we kind of get into what AiDash does and how Entergy has utilized this technology, I want to talk a little bit about AiDash to get everyone familiar. So AiDash is a satellite technology company. We were founded in 2019. We have offices across the United States, Austin, California, as well as Reston, DC, as well as globally. We have an office in India, as well as London as well. We do have some partners on the professional services side, Boston Consulting Group. You'll also see some of our satellite imagery providers that were linked with some of their constellations, such as Maxar, UP42, GEG-SAT. Going into the middle of the slide, we most recently closed our Series B funding round with $33 million. Some of our investors may have names that look familiar to you, such as National Grid Partners, Edison International, G2VP, Shell, and BGV. That round last closed October of 2021. And in terms of a company, we are most, in terms of a company, oops, I think we have a little slide issue. In terms of our solution, we're currently deployed on 500,000 miles of T&D assets. We're not just deployed in the US, we are deployed globally, which we'll get to later. And we are the first provider to do and provide the solution at scale. To kind of show you how that demographic breaks down, we're currently deployed in 41 to 50 states in the US. You can see the map on the left-hand side. We're also deployed globally, actually right now in 5 to 7 continents. This is really important as you look into the technology. For those of you that are familiar with artificial intelligence and data science, having your model and your algorithms customized and trained on different types of environments is crucial for making this analysis work. We are one of the only companies that has this depth and been deployed successfully in this amount of territory. So as we kind of lay the foundation of satellite imagery and how that looks today, for example, before I began working with AiDash, my understanding of satellite technology or satellite imagery was logging into Google Earth and seeing my car from 10 years ago. It's still parked in my old driveway. But the truth is, there is a lot more to satellite technology today. On this slide, what we're seeing are 3 different imagery sets. So for example, in 1972, you see a Landsat 1 image. That was 1 pixel. And basically, we had tens of meters of accuracy, so there was not too much we could do with that. As we go to the middle, we see that same pixel today using 30 centimeter resolution, which is scalable and completely available, most parts globally today. And even as we look into the future, as reusable rockets have increased the amount of launches that we see and the amount of these satellite imaging sensors going up, we are going to see 10 centimeter imagery scalable and available in the short term, about 2 years. So right now, currently, actively, we're using 30 centimeter imagery, 50 centimeter imagery, and we're expanding that down to 10 centimeters in the very near future. One key thing I want to add is as satellites are perpetually in orbit, as they have been for 50 years, they're always acquiring data. So they're taking snapshots, they're getting this imagery, whether we are asking for it or not. And that becomes an important fact as we get later into this presentation. As we expand deeper into satellite imagery and what we actually do with that, it's a temporal view. So as we look at Google Earth, for example, and see things that have been altered to make sense for our eyes in that RGB spectrum, when we task satellite imagery, we're not using that. We're using something called multispectral. This is one of the imagery types that we use today. What that means is there's a bunch of different bands of light reflection that we use to perform our analysis. That gets important as you get into the infrared or the near red edge bands of spectrum, because that allows us and unlocks the ability to look deeper into the things and understand more about the attributes we're looking at. So for example, we look at the red edge band of spectrum to understand tree health. We do that by measuring chlorophyll contents. We're able to actually identify soil conditions and measure that change over time to, for example, predict and manage danger and hazard trees. Right now, every revisit rate globally can basically be done in 24 hours. So there's always a satellite that can reach the same point in about a day. And again, the next short term, about 2 to 3 years, that revisit rate is going to go down to 1 hour. So every point on Earth could actually be scanned in 1 hour's time. That's because there's about 1,000 satellites being launched every year. That number is actively increasing, again, thanks to reusable rockets bringing down the cost of these deployments, making it a lot more available. So as we kind of look into the future and kind of think about what does this hold for satellite imagery, it's rapidly expanding. It's really becoming one of the most kind of future-proof technologies as we look forward. Beyond multispectral imagery, we also use something called synthetic aperture radar, or SAR for short. This allows and kind of unlocks two different things that we can do with it. So synthetic aperture radar is essentially, instead of taking an image, bouncing radar signals back up to the satellite, which can allow us to pierce through clouds. So for example, in a storm situation, actually pierce through the hurricane to figure out what's going on the ground. This also allows us to task satellites in the middle of the night. We do not need daylight for this type of analysis. And this brings back the same items that we could do for all of our analysis. So it is not needed to have completely free cloud cover. We can pierce through clouds. We can see out through the night, which unlocks a lot of different use cases, again, specifically looking at wildfires and storms. So putting all these pieces together, this slide kind of shows at a million-mile view how AiDash performs its analysis. So beginning in section 1, we're combining some data inputs from the utility. The only thing that we need to operate is a GIS shapefile. And the GIS shapefile does not need to be geospatially correct. We automatically correct that through one of our internal processes to make sure that that conductor location is geospatially referenced. So as we're measuring encroachment, we're certain that the distance that we're realizing and doing our analysis with is correct. We're also building growth models. This is one of the unique advantages of satellite technology, is as I mentioned earlier, they've been perpetually in orbit for over 50 years. So we can essentially time travel with this. What that really looks like as a use case in vegetation management is we're going backwards and taking imagery 3, 5, maybe even beyond, sometimes even to 2013 for some analysis. But we want to go back to where trim cycles were last trimmed or last pruned, so we can understand immediately after pruning, how did that vegetation invigorate out and then slowly grow over time. So by taking that historical analysis and merging that with the satellite imagery that we get today, we're able to build customized and observed growth rate models. This is really important when you think about a species-based model, because not every species, not every tree is created equal. For example, the maple in my backyard, even though it's a maple, is probably growing a little bit different radially or health-wise than the maple in your backyard. So by observing and measuring every pixel, we are getting that exact tree, its exact growth rate, and being able to predict into the future how that's going to behave. So once we have all of this data, going back years and years, merging that with what we have today, we're able to analyze clearances and encroachments at span level. We take all those span level encroachments, merge with some connectivity data such as reclosers and fuses, and aggregate that up into predicted trim years that could be executed either at the complete substation, the circuit, or even sub-circuit levels. If you want to get down to the span, for example, if you are in a hot spotting environment, that is possible today. But we do allow to aggregate that data up to be most actual fit within your plans. To get a little bit deeper into the growth modeling, because this is a unique concept to kind of understand, one important concept also with satellite imagery is we're not just taking a horizontal two-dimensional image. As satellites are in orbit, we're taking multiple shots of the same place, the same area of interest on Earth, and triangulating that back, kind of, you can imagine the Pythagorean theorem. That is called stereoscopic acquisition. That allows us to create 3D models. So if we understand different angles of the same place, we can then determine tree height, undergrowth, floor growth, and have a complete three-dimensional model, all from satellites. At the bottom left-hand side, you're seeing some of that analysis actually going on. So measuring the canopies, measuring the growth rates over time, and then determining the height of that vegetation to come up with a true radial clearance in terms of encroachment. We don't just stop there, because depending on years and seasonality, growth rates can change. So for example, in a drought or a very wet year, we do merge all this data. So for example, we look at topography. So how is the lean affecting that vegetation? How is the slope affecting that? Is that even eroding, for example? We do analyze soil composition. We do look at weather, again, looking at precipitation, what was the growing season for that year as we measured it from the satellite analysis, and fusing all that data. So this is truly a pixel-to-pixel analysis that can't be completed any other way other than artificial intelligence, because we're talking terabytes of data. But this is mapping out an entire network, every pixel, every span, and every piece of vegetation to allow you to make decisions of how do we manage this better as we move forward. To kind of glue this all together, we can kind of see that lifeline that I described in the previous slide. We see the current clearance detection we're getting from the multispectral or SAR imagery. We're fusing that with all sorts of topography, soil composition, weather data, and if there's any unique data specific to the utility, such as connectivity and reclosers, to look at that subcircuit view. We correct that shapefile, and then we run our AI models to help determine predictions for the future, and we glue that all together in a single system called the Intelligent Vegetation Management System. So what does that mean? What that really means is now there's this unique solution. Instead of using an approach such as LiDAR, flight aircraft, aerial, UAVs, to take a snapshot instantaneously on your network, using that time travel and historical imagery capabilities to make predictions for the future and not just have a data set that was a single point in time. By doing this and utilizing our predictions, most of our customers have been able to improve reliability by 5 to 50%, reduce their vegetation budgets or their spend by 10 to 20% by understanding where they should be at the right time versus spending dollars where they don't need to be. And the huge advantage is we can go live in 4 to 8 weeks on a fresh deployment. A lot of that time is spent correcting the shapefile and building the implementation. But once we have that, satellite refreshes can be done hypothetically every 24 hours, if ever so needed. So there is a very short time. There's no acquisition. There's no permitting or regulatory issues of having to fly lines to gather this data. It's truly just a snapshot, easy as click of a button. So to kind of get in deeper to this, we do have Heath, who's here to describe how Entergy has leveraged and implemented satellite technology into their vegetation management program. So I'd love to turn it over to Heath to tell you more about some of the reliability results that they've encountered after implementing AiDash.
Appreciate you, Jordan, for that introduction. And just want to give y'all a quick background of Entergy. We're in the Southern United States. We serve just over 3 million customers. I'm on the distribution vegetation side, and we manage about 92,000 miles of overhead line. That encompasses about 3,500 feeders or circuits within that area. Our annual budget ranges around $90 million, and we have currently about 8 what we call baseload vendors that do our day in, day out work, which is about 1,200. And when we're fully staffed, we may be up to 15 tree trimmers on property. To manage that workforce, we have 49 full-time employees that are Entergy employees. You see our hierarchy there. We got 4 state supervisors, vegetation OCs, got some leads. I'm the system analyst over here to the side. But that's sort of a history about Entergy itself. And how this came about was, we've seen a positive results since we implemented 2 programs or 2 tools, cycle optimization and the danger tree spotter tool. And I'd like to get into that with y'all today. And I'm not hiding things from anybody. I want to be serious and real with the group here. We were back in the late 1990s. We were really bad reliability wise when it came to vegetation. We were close to 1.4 million customer interruptions. And you can sort of see we had to go request some additional funding. The system was falling apart. Vegetation was encroaching everywhere. It was in shambles, really. So we were able to get the executives to give us some additional funds, and we were able to drive down our reliability to a more level playing field, I guess you could say, sort of baselined it here in the CI levels. And then we sort of played the budget accordion over the years. Some years were funded good, some years were not. But in about 2018, 2019, we started to see our reliability slip up to almost that 900,000 CI level range. And that's sort of an indicator that the system's on the brink of possibly going really bad. So in late 2019, so probably the third quarter, we started having some talks with executives. They were calling us in. I wouldn't call it to say it to the woodshed, but we were getting brought in saying, hey, guys, this is not good. Y'all are keeping us from achieving some reliability long-term goals. Vegetation, what can y'all do? And we really were scratching our heads. We thought we were doing everything right. So we started working with AiDash to try to figure out what we could do better. In late 2019, that partnership started, and really revamped our cycle trimming tool. And so you can start seeing here that really since we put this into play, our CI levels, customer interruption levels, have come down to I want to say last year may have probably been our best year we've ever experienced. So with that being said, at Entergy, much like many utilities, we're measured and tracked against all kinds of metrics, and reliability for vegetation is one of those. And as you see here, we have targets set, and we eclipsed all targets for all operating companies, including the utility year one. So that's very encouraging. After we implemented the IVMS tools from AiDash, we thought that was a great first start. So let's just go into year two. Was it a fluke, or are we on to something? Year two, the targets got even tighter, and we still performed better than the previous year, and we still eclipsed the targets across the board. So that was, for us, very, very positive results. And I'm going to share how we believe we got. Here is another thing. We have the tool that tells us how many miles we should trim each year. And then we also show you how many miles we're able to trim based on the funding we received. And probably 2018 wasn't so bad, but when you get into 2019 and since then, you can see what the blue line is actually what we were able to trim miles, and the orangish colored line is where we should have trimmed based on the model telling us this is the natural model. And we are slowly falling behind, and really, we need $22 million just to get to the natural cycle. So when you know you're underfunded at that level, and you also know that you're requesting this funding, but everybody's trying to reduce O&M, how am I going to keep reliability is continue to come in at a reliability level that is favorable for our executives? That's where I think the tools really come in. So let me just give you another background. I don't know if your costs have increased when you're at your utility, but in just the last 10 years, we've doubled what we pay to trim a mile line. Double. In the last 5 years, it's roughly 48% increase. And we had Hurricane Ida come in late August of this past year. We were actually about to put out a 2-year bid. We had some ideas. We're going to see between 15 and 30% increases over that 2-year bid. Unfortunately, due to the hurricane, we couldn't bid out the work. So we did an extension with our baseload vendors that were already our company. And that hit us for a 24% increase over what we paid in 2021. So we're not getting additional funding. The cost to do business is going up. So that gap of that previous slide where I'm showing you, it looks like it's steadily going to get more and more. So if that's the case, you've got to start really, really predicting, or I should say, selecting the feeders that are most impactful for your system, or your reliability gains that you've had the last few years. So one way of doing that was the cycle optimization tool. And this is the tool that the AiDash helped us with. This is every feeder that we have in the system is inside here. It's got a criticality score where it looks at customers, it looks at vegetation, it looks like, I guess you could say, effort, like how much vegetation is out there, your critical customers, how many outages have occurred on these feeders, and it starts ranking them to say, this is what you need to trim natural cycle, but this is what you have the money to trim. Which ones are you going to go after? And we normally go after these high criticality scores feeders because that's the ones that have the most impact. Those are the ones that can't be deferred out another year. So that's where we've made our most benefit since we have been under, but our feeder selection we think has been great. The awesome thing about the tool, every feeder in the system has its own natural cycle. It tells you when you should trim it based on our parameters are when 20% of the line is within 2 feet of the conductor. That's the trigger saying you need to trim this in the next year, or you're going to start having, some burn-in outages. But we have it at the feeder level. We have it at the network level. It rolls up to a region, and it rolls up to an operating company. This is the cool part. This is our second run. It's learning continually. But the second run, we also have 90% alignment with what the model predicts and then what our field validates. I went out last week and rode 4 feeders with AiDash, and we were just looking at some of this, hand in hand with just some of the local vegetation OCs. And we were probably closer to 95% alignment with what the satellite's telling us based on work type, density, clearances. It was just really amazing for me to actually lay eyes on it. So just to let you know, I'm not just the office guy. I did get out there and actually see it firsthand. So that was good. Another thing, I don't know how y'all get your trim plans and how it's built. We showed you had 49 employees, about 35 field employees. They would send their supervisors their trim plans on every spreadsheet, every type, every header you could ever. Now it can be done uniformly inside the tool itself. And so when an OC built his trim plan, he has a natural cycle, how many miles he should trim. And then he has a criticality score, and then he can pick and select that the supervisor can take all those, and then they can have those decisions and those discussions. Which ones do we need to really push out? Which ones have to be trimmed? And then they can build their trim plan here, and then we can generate that and get that to our contractor. So all that can happen in a one location, which for us was very, very helpful. I think Jordan mentioned a good bit about this multi-directional growth rate. We had a growth study from 30 years ago. It got refreshed 20 years ago. So when we started this thing from the ground up with AiDash, we gave them our species, our composition of species, the growth rates of those species by region, and then also the OCs had a lot of the clearances that were out there in our rural and our urban settings. And so all that was generated in how the model was ran. But we're hopefully, with the 33,000 miles that we're flying annually now, we hope to have our entire system completed by I think the end of next year. If that happens like we hope, this is going to replace all the human. We know we had OCs out there that never went in the field, never verified or validated what species were out there, what percentage of those species were on that feeder, what were your clearances. They just armchair quarterbacked it and just said, I think this, this is what I think's out there. Well, this is going to replace all that think with real time information, and the scans that we're going to have it's going to be great. We feel like it's going to really true up the I guess the prediction modeling on the feeders and take some of the human error that we probably had from the early on stages. So this is what we're really excited about. Again, another important thing, if you're like us and you have some rural feeders or long feeders, we have 170 feeders that are 100 miles or longer. Currently, about 34 of those feeders we've actually been able to segment. So when you have, let's just say, that I'll give you an example, pull this next screen up. This is probably close to a 300-mile feeder up in Arkansas. We were able to segment this in 4 segments, because if you're paying $5,000 or $6,000 a mile, and that's going to eat up a lot of budget to try to trim this feeder all at once. Whereas the satellite's telling us this is on a 3-year, this is on a 5, this is 6, and this is 7. And you can split them out at these device points and things like that. And we're always given AiDash, our GIS information on our feeder information. So we're able to keep this updated in the system. It's really been helpful. And we look like there's some opportunities for us to continue to segment some additional feeders on our system. So this could be where you could get those good splits of your rural and urban. Y'all may already be doing that. So I know some utilities just trim the trunk on a 3-year or 4-year, then they do the taps on a 7 to 8 year. This could even true this up to really tell you when those little segments need to be trimmed. And then it gives it to you in a real clean version inside the tool itself. You've got your parent feeder, you've got the history of the segments below it. So to me, the tool is really good, especially think about this. If you have a lot of turnover, a lot of that information knowledge would be lost, but now you've got every bit of history on that feeder inside of one area. The new person comes in, you create their user ID. He's looking at all of his feeders, all the updated maps, everything about the feeder is right there for him at his fingertips. So that's the optimization tool. That to me has been our biggest, driver to helping our program improve reliability wise, because like I said, the funding has not been there. We continually go, it seems like every quarter, to our executives asking, this is what we think, predicting if we don't get that funding, we think the reliability is going to start deteriorating. It's going to go bad. This is the predictions on CI increases. And they still are holding us and saying, hey, y'all are still doing very well. And only reason I think that is because we've been able to select the correct feeders. One other thing, this hazard tree spotter app, really great tool. We needed this. 80% of our problems really are outside right away, outside of our trim specs. And so we were able to create this tool with AiDash, phone apps, Android, Apple, out there in the field. The OC can do it. His contractor can log a tree. The servicemen, just more eyes out there finding these skyline opportunities, bad overhang, hazard tree leaners, whatever. And so we're creating robust backlogs. And so that helps us when we do have a lot of trees. We do get some hazard tree funding. It's not to the level we want, but we have seen the ability to backlog trees, go to our regulators, say we have identified 5,000 trees that potentially could cause major outages to our system, and then fund us for that to get those trees cut. So this has been really good to have that inventory, log it, have those trees out there. And just like I said, the extra set of eyes with everybody working together. We can assign a tree to the vendor here, have a bot built where we can click a button. It will create a work order, send the ticket to the vendor. So it's been very beneficial. Some of the newer things, I know I'm going fast here. We're in the Delta. I say that the Delta. We're in the Gulf Coast. We get hit with major hurricanes. We've had hurricanes Laura and Delta previously. Then last year, Ida just obliterated our system. At 30,000 plus poles damaged. But this is a way for us to true up and get the feeder had this much vegetation pre-storm. Then it gets hammered with a hurricane. Now it's this, just as the growth cycle. Feeders get reconducted. They get moved around. All that gets changed. And so the satellite imagery is always, like I said, it's able to scan that and tell us, okay, you got 50% less vegetation out there. You have more clearance. This feeder goes from a 4-year to a 6-year trim cycle. And it does it for us. We don't have to go out there and guesstimate and try to figure out, is it still in the same trim cycle? No, it's changed. It's been hit by a hurricane. Things are different. So that's one thing neat. I'll also throw out the fact that LiDAR and satellite, I get asked the question, is LiDAR information great? It is. It's very great. We piggybacked a big project in 2019 and got some LiDAR data. I have utilized it in some of our bid packaging and things like that. But as it is, it's a scan in time. It doesn't change. It's stagnant. It's great information, but day one after it's scanned, it's everything's assumptions. And so where a satellite can go do a scan and get you up to the date, we're still working off 2 or 3 year olds LiDAR data. And so for us to rescan our system was going to be very costly. We looked at doing a standalone LiDAR project. I would tell your company, your utility, if you can piggyback some other big project or pay a quarter or half of the cost, I would say probably would be worth it. But if you've got to do a major standalone LiDAR project for vegetation management, it was not cost effective for us. But whereas the AiDash products, and it fit into our allowable budgets for what we were looking for. And again, I didn't anticipate, I had no idea what the results would be after we did this. I just felt like we were making better decisions. And I think the reliability numbers after 2 years have shown that we have the tools that we've implemented that AiDash has helped provide for us, we feel like is the reason. Now, how long we can hold this, you can't continue to be 3,000 to 4,000 miles. As good as these products are, at some point, you have to have the funding to go trim what the model's telling you on the natural cycle. You just cannot continue to fall 4,000 and 5,000 miles. So we're working, that's not an AiDash problem, that's an energy problem, but we're trying to get to that. But I would tell you this without a doubt, that the feeder selection has been critical to us being able to maintain reliability to where it's at with those gaps in our funding. With that, I'd like to turn it back to the T&D team for a Q&A session. I know I went through that fast, but I just wanted to make sure y'all saw where we've been the last 3 years with AiDash.
Certainly. Thanks very much, Heath. We do want to get to your questions. And if you still have some on your, go right ahead and keep adding them. It's not too late. So let's see. We have a question here for Heath, and that is, Heath, how did you get internal support and build the business case for this project?
Well, that was easy for us. As I mentioned, we were coming off a very, very bad run, 2-year run of terrible reliability. The executives were already asking us for what we could do differently than what we were doing. They're pretty much saying what you're doing is not working, vegetation team. Y'all need to think outside the box. And so it was just like the perfect time for us to merge and look at innovative technology that was out. Partnering, like I said, getting connected with AiDash was that first step for us to say, we're going to step outside of our comfort zone. We're going to try something different because what we're doing is not working. We already had just seen the 2020 pricing that was about to come out. We knew we were going to be falling behind in our line miles, how many line miles we could trim. All that was coming together. And so we were sort of more open as a team to say, yes, I think we could use some help here. And so that's where we got the support from the leadership of our company. They understood, and they were willing to support us and even pick up some of the cost of it.
Well, that's good. We have another one here that isn't aimed at any particular person, but did you create your trim plan using AiDash based on the feeder level or the segment?
It would be considered on the feeder level for sure. I mean, it's taken each feeder as a whole, and it's going to give you that natural cycle. The segment, as I mentioned, was, and I'm hoping I'm understanding you correctly, the segment has its own, the way it splits that feeder up, and it gives its own natural cycle to each one of those segments. So it's really, we pretty much build it. I bet 95% of our trim plan is built at the feeder level.
This one comes to us from National Grid. Have you had any pushback from your contractors using the app or taking pictures in the field?
Not so much. It's really the train-the-trainer sessions that we had to get the OCs involved. Once we have enough, we call them cycle champions, they can create user IDs on the fly. If there's interest anywhere, there's interest with your contractors, we can create a user account with them, get them lined out with just in a few minutes. Super user-friendly. Very little pushback from the contractors. Matter of fact, that's a benefit to them. They can find more hazard trees. Now, granted, it goes into what they call a pending status if they find a tree, whereas one of our employees logs a tree, it's obviously backlogged. The pending means just because a lineman or a contractor finds it doesn't mean it's a tree we're actually going to cut. It still has to be verified. They'll take pictures of it. usually that working relationship with that general foreman in the field and that OC, they know what our expectations, which trees we'll take out. So once they get that trust built up, a lot of times that OC will go ahead and move that pending tree to backlog and get it worked. And that's usually how, but very little pushback from our vendors or our contractors.
Yeah, we have actually another one for Heath from PPL Electric Utility. Do you use a standalone work management software system? And if so, how did you integrate the AiDash insights into your work management planning approach?
Well, I guess our work management system, we really necessarily didn't have one robust enough to do what we needed. We have our own outage programs and things like that we can pull our data from to know which, how feeders are performing. We were tracking our work in a process that probably wasn't as efficient as it needed to be. This platform here, like I said, we had the data. We just needed to get it all into one place where it all could be gathered, filtered, everything could be seen at the same level with the same data. We had it all before. Like I said, it was all around the world. Each state operating company wanted to do it their own way. They wanted to put their own flavor to it. And we needed to get centralized. We needed to be uniform. And so this AiDash platform sort of really helped us. We had a work management system. As far as it's integrated, it doesn't necessarily talk with some of the work order type systems like a Maximo or Click, but that interface possibly could be there. I mean, we're building bots to go create work orders from the Hazard Tree app. So there is a connection there that can be done.
We have one here from Eversource Energy. Was there a specific strategy or criteria used to identify which feeders to use the segment approach compared to a feeder approach? You mentioned 100-mile feeders where segmentation made a significant difference. So was that solely based on a specific length threshold?
For us originally, right now, it's been mostly a length threshold, taking the long feeders. We feel like we have some opportunities in our urban settings where we from some benchmark studies, we've seen where some of the utilities do split out their urban, in segments like that. That's something we would like to look at, and that would narrow down probably to some of our 25 to 50-mile feeders. And so that's just something we wanted to start somewhere. And for us, it was originally the length of the feeder, but now we're going to come back since we're going to have pretty much the entire system scanned by next year. That's going to allow us to look at the effort index, know where our work's at, how much work's out there by which type. And we may be able to split out, hey, the rule can be giraffed, trimmed with more mechanical. And then this is going to be more of your urban backlot climbing. It's going to have to be, more intense work, probably not getting the clearances. So we're going to look for those opportunities to start splitting some of our segments into smaller length feeders.
Yeah, good insights there. We got one from XL Energy. Do you use the tool for cost estimation? And if so, how accurate or close is it to your prior cost before AiDash?
Interesting question. That is one that we are trying to perfect as we speak. Working with AiDash, going out with Jordan last week, that's the one thing we were aligning was the work type. As we get some ideas about how much a mile a bucket is, how much a mile of intense trimming, climbing would be, or giraffe trimming, rule feeders, we're going to do we call it a should cost modeling, and it's getting very close to perfection there. We look like we could have something, because we would love to have it like we're putting out a major bid package and early next month. And so in about 3 months, we're going to have everybody's results in and what they bid. It would be really good to have that should cost modeling against what the vendors, to give us some kind of leverage. For the last few years, we've been seeing these increases, and we just haven't known what really a feeder should cost. But I do believe we are getting very close working with AiDash, and I think we're going to have something. So when we give it to our supply chain group and the bids start coming in, they're going to see the outliers. Hey, we agree with this. 80% of these costs seen them in line. Hey, these outliers, we're paying they're asking way too much money. We're not seeing it from the side. Explain yourself, or tell us why you say it costs this much. And so if this all plays out like we hope, we should have a lot more leverage than we've ever had when it comes to discussing or negotiating feeder costs.
Just to add to that a little bit, Keith kind of mentioned work type identification. Obviously, we're just scratching the surface in terms of this presentation, but one of the things that we are working on is actually accessibility or work type monitoring. So every span on that network has some type of accessibility paired with it. So for example, is it bucket work? Is it manual climbing? Is there enough room in that specific span or area to get a backyard bucket set up? Or is this an off-road or some type of mechanical type trim? So that does go into the model as well. That's an output that Keith is currently working with. And that has a direct effect of how we actually model costs, because if we understand the contractor's accessibility and crew types, we can then therefore refine the costing to improve the predictions.
We had one come in for Jordan. What are some other utility use cases that you're seeing for satellite technology?
Yeah, that's great question. Again, even with the work type inspection that we're doing, that's just getting into some of the other aspects that we have specific for vegetation management. Directly correlated, we currently have at scale and deployed a disaster management solution. So for example, storm modeling and storm predictions. If we understand all the vegetation on the network, we can then therefore predict using live storm data where outages, where vegetation outages, what's the total impact to CIs across that network. So utilities can then therefore get ahead of how much mutual aid am I going to request? Where do I actually place them? And do I have any opportunities to do some last minute storm hardening to prevent some of these large issues? We're doing some sustainability things so we can actually monitor biodiversity. So for example, look at the transmission flow in a right of way, figure out the biodiversity, figure out the habitat, and actually monitor carbon being sequestered to quantify things for green objective goals. We do some pipeline encroachment monitoring, so maybe not just vegetation, but any type of change detection, as well as getting into the transmission side of things of really monitoring floor, identifying opportunities to increase pollinator habitat and all of that. Really looking into the future, next 2 years when 10 centimeter and the hyperspectral bands become available, we'll be able to do some asset inspection. So actually visualize cross arms, look into broken and corroded insulators, look at thermal bands to understand hotspot in the conductors. So that's really going to be a powerful tool that's up and coming here very shortly.
It's a lot of applications across industries there. We had one come in from National Grid. How difficult was it to change the operations culture to accept this process change?
It was not as difficult as one maybe would think. We had a little bit of pushback, hence why we probably were going negatively or trending negatively, was just because of the fact they didn't want to accept change. It was a very small pool of our employees. So I would say that the culture change or getting them to believe into the tool or change was I think you'll have it at any utility. We probably had 85, 90% buy-in with just a few of your outliers that we just had to really work with. And but again, once they got into the tool, once they started seeing that their stuff was not scattered in spreadsheets everywhere, they could go in there and monitor everything in one location. It sort of changed, and it sort of started getting that support. And I saw it firsthand. Like I said, it was probably a few months period. And then once we got all the questions answered and they started playing with the tool and learning it, it really took off from there. And it just become less and less and more user friendly for them because they were utilizing it more often. So I guess you could say, yes, you're going to have a hiccup. I think any rollout of a new program. But again, this one was so beneficial to them in the long run and the short term that they saw the benefits of it. And really, we've got great support with AiDash's team. So if there is any kind of glitchy thing that happens, we have our weekly calls. We discuss things. It gets corrected very fast. So that from a usability standpoint, it's not something that lingers and it's an issue for months and months. It gets corrected very fast. So I think that's something they really better than what the Entergy can do on our IT side. So they sort of laugh and say, yeah, AiDash does better than our own internal people, which I hate to say it, sometimes true.
Good problem to have. The Omaha Public Power District sends a question. Have you ever used this technology to assess post-storm damage, not only to trees, but also overhead equipment? And if so, how quickly can that be done after the storm in an area where you have an existing model?
Jordan, I can only speak on the post-flight. We did do LoRa. That was our targeted approach. But as far as the other component of it, I'll let you take that one.
Yeah, definitely. So as Heath mentioned, in terms of vegetation change detection, that's something that's available today. As I kind of noted on that asset inspection piece, the technology is getting there. In about 2 years, we'll be fully able to do that with the 10 centimeter and hyperspectral imagery. Right now, a little bit limited as we get into some of the things that matter in terms of looking at insulators and getting that fine granularity. But in terms of turnaround, again, satellites are revisiting every point on Earth within 24 hours. And obviously, if this is a major event, you probably have some warning to do that. So what we do is we'll begin already figuring out what satellites we're going to task and when we're going to do that. If we need that SAR imagery to pierce through the clouds, it's something that will line up. So there is a bit of a process, but theoretically, if you call today, we can get that imagery hopefully within 24 hours. But again, hopefully there's some lead planning time if it is going to be a substantial event.
Good. Question here from Consumers Energy. Can you optimize for reliability benefit given your cost? Does the tool tell you what expected reliability benefit you'll see if you do the work plan?
From our standpoint, it's got our devices. It's got the amount of customers behind a device. It's not necessarily, this tool is not necessarily predicting what reliability will, but it obviously the criticality score and the effort index and all those things that go into that criticality score is pretty much telling us based on all the inputs which feeder is going to have the most impact. It's not actually. We're doing that within some of our data scientists within the Entergy on some of this, what you're asking. It's not necessarily in the tool itself that I know of, but it's not something that's not past possibilities of working with AiDash to add in. I think them having all of our data, outage data, things like that, they could do some predictive analysis for us in that standpoint. But right now, we're doing it internally for the most part.
And just to add to that, obviously, perspective by perspective basis, some utilities such as Heath and Entergy have a really robust reliability department with data scientists that are currently doing this internally. We do have the ability to project the impact to Sadie and Katie and actually look at vegetated related outages and CIs within the tool. But again, we kind of work together depending on what each client customize those expectations as needed.
We have one from the heart of Texas here for Heath from Encore Electric Delivery Company. You may have mentioned this already, but what or how high were the switching costs to go from your previous methods to using satellites?
Not to get into the particulars exactly, I mean, that obviously is some of the executives signed off on some of this. We got the benefit of them paying for some of it and us paying for some of it. Let's just say that it'll amaze you how cost effective the contract with AiDash is compared to our LiDAR project, from what we paid for LiDAR or what we're doing a post Hurricane Ida LiDAR flight. We're not paying for it. Again, that's where I sell a utility vegetation management, piggyback somebody else paying for the LiDAR and just get the benefit of it. But, LiDAR could be $100 to $120 a mile. Just for us to scan our system could be $15 to $20 million annually. That's just not set up in the O&M budgets, in a lot of cases for people to do that. But our contract with AiDash has been one that we split the cost by operating company, by the amount of miles, and it's obviously one of those expenses that's been able to be gobbled up and absorbed very, very good and without a lot of pushback, just because we feel like we're getting the benefit. It's more than paying for itself. And let me add to that real quick. Y'all have a call out, Encore, Entergy, everybody, when you have a lineman roll to go replace a vegetation outage or fix a vegetation outage, regardless if it's a grow-in, they got throwing a fuse, that's very easy. But if it's a tree that falls, tears down, breaks a couple poles, then you got a crew call out. There's a cost associated with that the company can benefit. Like we reduced our outages by 6,000 outages last year from the norm of the bar being around, say, 20 to 22,000 annually. We were probably below 15,000 outages. That saves the company a ton of O&M for repairing those outages. And so with that being, there's just cost savings all across the board, not just us getting good reliability. Your company could save a ton of money just in response to outages. If you're reducing outages and creating less grow-in outages, the one thing I didn't touch on, which I would love to, some of that multispectral imagery. Our next big project with AiDash is going to be tree health modeling. We know the problem areas. We know where we have the most outages. And if you're like us, your outages aren't always going to be your grow-ins. It's going to be things outside your trim spec, your overhang that's 20 feet above the conductor, or your trees outside your normal right-of-way. If we can use this modeling, we can tell AiDash where we think our problems are. They can take that multispectral imagery and start telling us, identifying trees, or at least down to the span or a number of trees inside of a span that could be potentially causing problems. We're about to see our reliability really, really improve. And so I think that alone, those are the big outage hitters that are going to cost your company $5,000 or $10,000 per repair job just because it's tearing up poles. Those are your ones we want to really prevent. So we're looking forward to that, hopefully in the very near future. That's one of our next big projects we want to use and work with AiDash on.